And we should be live. Howdy, howdy, everybody. We're a little bit early today. Not the end of the world if we're a few minutes early, right? Howdy, howdy. I hope everybody had a good night's sleep. Oh no. Is this the only topic for tonight? Well, it's not nighttime, it is morning, but yes, this is the only topic. We do this on Tuesdays and Wednesdays. Oh no, my water bottle is not full. Oh well, there's still a little bit of water in here. Did I sleep? I did. My cat has been very good lately. So we're, you know, well rested, if you will. Am I insane for thinking the old idea would show? I don't know what that means. I'm in Australia, sorry, it's late for me. I have such a loving wife, everybody. She loves me so much. I don't know why, but she does. It's wild out there in Flurfland. Yeah, that's why you gotta do it in bits. You gotta do it in bits and pieces, right? I woke up crying and covered in poop every few hours. That sounds like a you problem. How do I get a wife while doing my PhD? Well, the easy solution is to be engaged before you start your PhD. I am 7'11". That's how tall I am. So all those short kings out there that are 6'5", it's okay. You guys will find girls eventually. All right, let's answer some questions. Do you need to know linear algebra to fully understand spacetime? Yeah. Yeah, you do. You absolutely do. I mean, like, you need differential equations, you need linear algebra, you need partial differential equations, you know. Really liked your extra electron video. What would happen if every atom lost an electron? Literally the exact same thing. Literally the exact same thing. In all honesty, how far away are we from a theory of everything? We have no idea. These are the kinds of things that like take a particular strike of insight, and those come randomly, right? Thank you. Oh, why is it wet? It's okay. How did you know math was for you? Well, everybody had to do math, and you know, like in grade school or whatever, and I was good at it. On a live the other day, you spoke about the first and second law of thermodynamics. I learned energy can be neither created nor destroyed. It seemed there was disagreement. Clarify, please. Yeah, so look, as far as chemistry is concerned, that's just as good a law as you may ever be concerned with. However, on a cosmic scale, it just doesn't seem to be true. We know the conditions that must be satisfied, like we know the physical conditions that must be satisfied in order to have energy conservation being true, and energy conservation allowing for the, you know, for the truth of the second law of thermodynamics as well. And those conditions are not satisfied for our universe. Modern physics ignores Faraday's discovery of a dielectric medium governing energy transmission. As far as I'm concerned, modern physics can be safely ignored. Okay, well, then you can be safely ignored. What part of physics is your favorite? Anything geometric, really. Dr. Blitz, what was that long chat on Ian's stream yesterday actually about in a sentence or two? Because we were all scratching our heads, at least I was, and what was the conclusion? He was running an argument. He was running an argument that the existence of laws and the things those laws pertain to having a relationship is evidence for the existence of a god. He also ran the, no, I'm sorry, that was a different guy. The long conversation yesterday, he ran an argument that was basically everything needs an explanation, and that explanation has to be God. That was the gist of it. It was an involved and kind of more sophisticated version, but that was roughly it. What happened to the Magaverse science streams? It seems less prudent right now, or not, prudent's not the right word. It seems less important right now, considering science cuts are not in the media anymore. Bills have already been passed. This is not like there's not up-to-date stuff to talk about, so it just seems less prudent. Are they going to return? Maybe in the future. Could a quantum computer simulate life? As far as I can tell, no better than a classical computer could. Pertinent, thank you, that's the word, not prudent. What is the strangest or most mind-blowing thing coming out of physics field right now? Well, physics is a huge field, but like there's a lot. If you're asking for like mind-blowing, it's hard to say what's coming out right now. Like the fact that we were able to detect gravitational waves, this was 10 years ago, which is a while ago now. We were able to detect gravitational waves from 1 billion light years away, from 2 colliding black holes, and those waves wiggled space-time, a 4-kilometer length of space-time, less than 10,000th the width of a proton, and we were able to detect that. That's pretty spectacular, pretty impressive on my end, or in my view. It's like mind-blowing. Do you ever encounter the silver fox person in your lives? No, I haven't. What is the best part of your current studies? What do you enjoy? What part do you enjoy most? So arguably the part that I enjoy most is working out the details. So I'll have some concept that I have in mind that I want to see if I can make the math work out for, and then just working out and then like seeing it all work. That's really satisfying. Quantum computer only processes certain physics. It really can't. What? I don't know what the question means. Does energy equal mass times velocity? No. You're thinking of the classical expression for momentum. Any proof of a proton actually existing? Yeah, absolutely. We have anode rays. Those are literally particle beams of protons. You can detect individual protons. In fact, protons are merely what happens if you put hydrogen, and if you get hydrogen really, really hot. Is it possible that someone defines everything in the next 10, 12 years? I don't know what that means. I don't know what you mean by defines everything. Where can we apply Einstein's formula of relativity? Relativity in some sense applies everywhere, except maybe, so the general relativity applies everywhere, except maybe at the, what is happening? What is happening with the chat? Maybe at the super quantum scale. Can you replicate gravitational waves with sound waves? No. Are you a materialist when it comes to consciousness? I don't know what I am. I'm like some sort of physicalist or materialist, or the things that I think that are real are the things that are like made of stuff, if that makes sense. Is purely abstract mathematics useless, like the kind that isn't really practically useful? I would say no. As far as I know, there's mathematics that was done in like the 1800s that we're just finding use for today. And at the time, it was viewed as like, completely abstract. But it's not clear that will always be the case. Can we use nuke explosions to send a rocket like super fast? Yeah, this was an idea. Look up Project Orion, I want to say. From the 60s, they were thinking of using nuclear detonations behind a rocket in order to get it up to very high speeds. Is traveling through a wormhole theoretically possible? Not really. That would require a stable wormhole that you could travel through. And as far as we know, those aren't possible. They require a certain kind of matter that we just think doesn't exist. I need some coffee today? Not yet. Not yet. Will expansion of the universe lead to implosions, which lead to another Big Bang? We don't know. We just don't know. Vanion Muramasa, thank you for the $10. Any thoughts on the thermodynamic sampling units coming out of Xtropic? It seems like hype. I've seen a TikTok video about it. It just seemed like a hype video, but I haven't looked into it at all. It could be neat. It could be neat. In Einstein Cartan theory, torsion is algebraically tied to spin density. Is there a geometric reason it doesn't propagate like curvature, or is that just due to the action we choose? Yeah, that's just basically due to the action we choose. If you mean why the torsion doesn't have any dynamical degrees of freedom, yeah, that's just due to the action. You can include torsion in your action if you want to. But you don't have to. But I don't really work on Einstein-Cartan stuff very often, if only because, like, my view is, unless we have reason to think that Einstein gravity fails somewhere, then it seems like we shouldn't be looking for alternative models of classical gravity. It seems like, I mean, like, of course, other people can do whatever they want, but I assume GR is true until GR seems to fail. And we don't have any data that says that GR fails, so. You've described the expansion of space as enlarging cells in a spreadsheet. What are the cells in this analogy? A cell is just like a volume of space. Will you be attending the March-April meeting? Maybe. I haven't thought about it yet. I haven't thought about, like, like you're talking about the APS meeting, right? Because I already have a conference that I'm going to in April, or in January rather, at the end of January, and so it's not super clear. Can you explain what closed time-like curves are in general relativity? Yeah, so a closed time-like curve is merely it's a path through space-time that doesn't only travel forward in time, but at some point it travels backwards in time and loops back on itself. It's closed, and yet it's time-like, meaning it only travels in time. Which means that a person could in principle travel along it. However, as far as we can tell, such things, again, require very exotic types of matter configurations to form. How's research going? I had a few interesting ideas that might become projects in the near future the other day. So I'm finishing up some other projects, and then I'm going to start working on some new projects soon. In theories like Poincare gauge gravity, torsion has its own wave solutions. Are those gauge artifacts, or do they correspond to genuinely propagating geometric models? I'm not familiar with Poincare gauge gravity, so I can't really comment on it. Based Ashura sends $5 to ask a wee bit off topic, but I'd like to get your opinion on AI being used in patient-provider bedside medical care. Oh, I don't know. It's not my area. It seems like I don't even know the context for this. I don't know in what cases, what situations it's being used. Generally, I would think that patients probably wouldn't want to interact with AI. They'd rather interact with people, but if I don't know what you're proposing is true. So, how was your experience with your professors? Were they good at teaching? I had one professor or maybe two professors that I didn't think that were particularly good, or I didn't like them, or I didn't get much from them. One of them was a thermodynamics professor. Actually, both of them were thermodynamics professors, thermodynamics and statistical mechanics professors. Maybe that's why I don't like statistical mechanics. Well, I know that that's why. But do you have something you would recommend for a future theoretical physicist? What do you mean something I would recommend? Are electrons real? Has anyone seen it? Negative charge is measured? Yeah, you can measure the charge of an electron, and you can definitely detect individual electrons. Yeah, absolutely. How does your type of research proceed? I assume you don't collect and analyze data per se. No, so the only data I ever interact with is data that I find elsewhere, and I use it to either, support some argument that I'm making, or, provide motivation for some model I'm proposing. So at least that's the physics research I do. So the kind of physics research I do is like very model building. So I'll consider, like, okay, here's a possibility. Can we rule out its behavior? Can we describe what's required in order for it to agree with observational data? Those kinds of things. The mathematics research I do, well, there's not really data in mathematics anyway, so the question kind of becomes irrelevant. How electron charge is measured? Is there any machine? So we can actually measure electron charges directly with electronics, right? Like, you can just shoot an electron beam at a piece of metal, and you will detect a current. In your opinion, do you think you are a better physicist or physicist professor? I don't know what that means. I don't know what you mean. Do you mean like a teacher or a researcher? I don't know. Good morning, Dr. Blitz. I heard PBS spacetime that some quantum fields have a vector as well as a value. Does that mean for a field to wait a minute. Have a vector as well as a value? What does it mean for a field to have vector? So yeah, for example, you don't even need quantum fields for this. The electromagnetic field is technically it's a tensor valued field. So it has 6 components rather than 1. So at every point in space, there are 6 components relating to the electric field and the magnetic field. In the electric field in the x, y, and z directions, the magnetic field in the x, y, and z directions at each point in space. So there are 6 values. I guess it's technically like a 2-form valued field, but yeah, so there's 6 values associated with every point in space-time rather than just 1. I assume that that's what you're referring to. Physics dropout here, math hard. Yeah, fair. Love your content, man. Keep up the fight against misinformation. I appreciate that. Can you comment on non-commutative geometry? So I've only dabbled in non-commutative geometry a bit. I guess typically what you do is what you want to, so the kind of the way that we talk about geometry abstractly is as functions on spaces. And you can have functions of non-commuting algebraic variables, no problem, rather than functions of, say, coordinates, which are commuting. And so you can do when we talk about non-commutative geometry, what you're really talking about is like algebras of functions that either commute, don't commute in various ways, and then you can kind of build analogs for like a metric, which is a distance function. You can build analogs for a connection, which tells you how to move, how to move in a straight line. You can build vectors and all sorts of things. And so I actually think that that's probably personally, I think that that might be a useful way to proceed as far as describing quantum gravity, but that's me speculating. I've heard that if 2 high-energy photons collide, they create matter. How does this work? This is called the Schwinger process, if I remember correctly. Let me make sure that I'm getting the name right. The Schwinger effect, I'm sorry. So the Schwinger effect is what happens when, I want the diagram so I can show you. It's like the multi-photon. Multi-photon. There's also 2-photon scattering. Okay, no, sorry, the Schwinger effect is a separate thing. 2-photon scattering is a different thing. This is the diagram I was looking for. But that's not the thing that I wanted. No, I wanted this one. Here we go. Let me show you what I mean. So here's the diagram. There we go. Yeah, so this diagram here, the display is being spammed and I don't understand why. So this diagram here demonstrates 2-photon scattering, but basically what you need, so you have 2 photons on the left. These are the wiggly lines. One sec, let me have it capture my cursor. 2 photons on the left, anyway. The 2 photons on the left come in with the wiggly lines. They exchange a virtual electron or a virtual positron, and out comes an electron, which are the straight line, and a positron, which is the other straight line. Now, what's required is that the total energy of the electron-positron pair must be at least as smaller than, well, it has to, in this case, has to be exactly equal to the total energy of the 2 photons. And so, in particular, what that means is that you have to have more than a mega electron volt worth of total energy for the 2 photons, because an electron and a positron both have an energy of about 500 kilo electron volts. Does theoretical physics have a future in science progression? Absolutely. In your opinion, a wave function is just a math tool for predictions or a real thing that exists in the nature of the world? What is your preferred interpretation? I prefer the many worlds interpretation. I think that it's a real thing. Or rather, I think it describes a real thing. Just a token of appreciation. Thank you, Hugo, for the $3, the 3 Australian dollary dues. If we measure time using man-made instruments and time is just a measurement given from those instruments, how can time really exist? Well, you could say the same thing about everything. Everything is a man-made instrument, even our eyeballs. We make our own eyeballs in the, in the womb, if you will. And so you could say, how does anything exist if everything is just a measurement from man-made instruments? But that's just not like a good way of coming to ontology, right? Can you solve a Rubik's Cube? No, I cannot. I never learned. I heard the expansion of the universe is slowing down. Yeah, there was a paper that came out a few weeks ago that proposed that that is the case, and they have compelling evidence to suggest that that's true. Now, we should probably wait, be a little bit cautious before we, definitively believe that, but it's definitely interesting. How well do we know the physics of the how when electromagnetic force succumbs to the strong force? Do you mean like like when the electromagnetic force gets overtaken by the strong force in like the nucleus, because that we understand fairly well. The electromagnetic force is really well understood, and we have a bunch of fairly good empirical models that describe the way nuclei are held together, with the strong force holding them together and the electric force or the electrostatic force repelling them. Do we need triple integrals in physics? Absolutely, you do. Does string theory show that we are all connected at the fundamental level? No, it has nothing to do with that. Is the speed of light the same as, is the speed of time the same as the speed of light? If yes, then if light travels slower in different mediums, then does time, no. So the speed of time is not the same as the speed of light. I actually don't even know what that means, really. Are dimensions infinitely bigger than the one before? What? I don't know what that means. Do you ever feel like we're too confident about what we know, especially when you look at history? In one sense, yeah, absolutely. We should be epistemically humble, if you will. However, what is true is that we've gotten just a lot better at doing science. And I don't mean like we know more. I mean that we are a lot more rigorous. We are a lot more precise with the way that we do science these days. We run double-blind experiments. We run fake tests to make sure that we're not like picking up on fake signals. We have like strong statistical constraints. We do all sorts of bias checking and things like. We're just better at doing science and ruling out things that can lead to false conclusions. So I would say that we probably should be more confident now than we should have been 100 years ago. Now, whether that means that we're actually coming to true conclusions is a different story, but we should at least be more confident that we're coming to true conclusions. Is space-time doomed and should it be replaced with a more primitive geometric structure? Maybe. We don't have any experimental data that really indicates that yet, though, so. What do you think will be the next biggest discovery in the next decade? If I knew that, I'd be out doing it rather than and winning my Nobel Prize, right? At what point could science become dangerous? Science is a method. It can't really be dangerous. It's just what the method ends up being used to develop that can be dangerous. Are the 3i Atlas updates interesting for you? No, not at all. They're wholly uninteresting to me. I care zero about them. It's a space rock. Can physics help me elongate? No. Is gravity a force or a part of space-time in a way we can perceive? They're the same, like, they're not mutually exclusive. Gravity is a force insofar as it causes a transfer of momentum, and it comes from a curvature, and it's part of space-time because it's the curvature of the space-time. They're not opposing each other. Those two things are not the same thing, are not opposite. What is the boundary of the universe? As far as we can tell, there isn't one. If nothing travels faster than light, how does entanglement stay perfectly correlated across the universe? It's a correlation. It's just a correlation that exists. What's the thing that's actually traveling? Is time really influenced by gravity the way the movie Interstellar suggests? Absolutely it is, yeah. If the universe is flat, how come the Earth is a globe? Well, flat doesn't mean two-dimensional. It just means not curved. By the way, remember to share this with friends who might be interested. It's a good idea to get people interested in physics, right? So they can ask questions and get their questions answered. Also, make sure that you follow the new channel, you subscribe to the new channel on YouTube, which is Dr. Blitz Debunks, if you like that kind of stuff. Go check it out. There's some fun videos there. Yeah, 3i Atlas is literally just one guy babbling. Yeah, it's like literally fueled by just one dude. Does two-photon physics imply the electromagnetic field is nonlinear at high energies? Yeah, it does. Does the slowing of the expansion of the universe hint at a finite space or finite mass? No, not necessarily. Is it true that it's hard to get a job after a physics degree? I'm from Austria. In physics, yes. That is the reality. It's hard to get a job in physics because there are just not many jobs in physics, right? Do you like Neil deGrasse Tyson? I think he does a good job exciting people about science. I think that that's like a positive that he contributes to the world. How does gravity curving space-time cause things to fall when let go? So everything is always moving through space and time, right? If it's not moving, like, you can't stop something from moving through time. And so if something is moving through time and time curves into space, for example, which is what happens near the Earth or near any central gravitational body, then when you let something go, even if it's not moving through space initially, because time is curving into space, it picks up some spatial motion, and that's what we call falling. If a blitzar collapses in a couple of milliseconds, could it collapse in stages that we aren't capable of seeing yet? If we could get close enough, technically, could we use slow-mo cameras to study that? Yeah, in principle, sure. What sigma is the new slowing of the expansion? It depends on what way, like the way that you're framing it, but like they had like 5.5 sigma or something like this, which is huge. Adolbilla sends 5 Canuck bucks. I'm not sure if you would know when considering Gaugino condensates. They look at Vev of the trace of lambda lambda. Do you know what the trace of lambda lambda does? I have no idea. I don't do any supersymmetry stuff. So I wish I could answer your question, but I can't. Yeah, I not only do I not care for supersymmetry, I don't like it. So like it stays in its lane and I stay in my lane. C-Bar sent $5 to ask, thank you, C-Bar. If mass curve spacetime, how wide is the universe flat? So the idea is that the universe is flat absent any matter. If you put matter in, then there's going to be distortions. But the universe didn't have to be flat absent matter. The universe could have been spherical absent matter, or it could have been hyperbolic, which is kind of like Pringle shaped, but three-dimensional, in the absence of matter. It just happens that our universe seems to be flat in the absence of matter. And we can measure that by looking at large-scale structure. Blitz, unlike Tyson, was Carl Sagan more than just a science champion? Carl Sagan was a special figure. He was a delight, and I think that Tyson. I don't think Tyson has filled those shoes because those are really big shoes to fill, but he does his best. What is defined as space in the context of expansion? If I put my hand 1 foot in front of my face, is my hand slowly getting further away due to expansion? So the expansion, the way to understand the expansion and where the expansion happens is it only happens where there's nothing. It only happens where there's no matter. And the reason is because the matter is held together very tightly. And so the presence of matter, the presence of that energy holding the matter together, basically stops the expansion from happening. But when there's no matter around, or when there's very, very little matter around, then the space will expand. Is there something outside our universe? It depends on what you mean by universe, but you can kind of define the universe as everything, in which case the answer is no. Is it worth to become a theoretical physicist? You don't do it for the money. What's one branch of physics would you like to get some more attention? My branch, obviously, relativity, mathematical relativity stuff. Space-time isn't flat, that's just a model. Well, space-time isn't, spatial slices are. And this is something that you can measure. You can measure the curvature of spatial slices, and we measure them flat, at least with respect to cosmological time. Am I too dumb to learn advanced mathematics and physics? Well, I don't know you. I'm going to say no. Does the energy that is wasted when the universe expands turn to black matter? The expansion of the universe defies energy conservation. Is there many worlds interpretation at odds with the idea of decoherence? No, decoherence actually fits nicely into many worlds. Why does time go faster around denser gravitational forces? No, it's the opposite. Time goes slower. So you will, if you're hanging out near a black hole, you will experience 10 minutes, and somebody else might experience 10 years, depending on how close you are. Did you need physical chemistry? Did you need physical chemistry for your degree? No, not at all. Are Pringles two-dimensional? Well, I mean, like, the surface of them is. It's like a two-dimensional surface. But, like, obviously they're three-dimensional objects because they have thickness. Can you explain the concept of superposition? Yeah, so superposition, it's actually not that hard to understand because it's not just a quantum thing. It happens whenever there are two waves or two or more waves. So a good example of superposition is the sound wave that's produced when a guitar string, or when a guitar plays two strings at once. It produces two sound waves that overlap with each other, and that sound wave, so you can describe the resulting sound wave, the combined sound wave, as a superposition of the two different sound waves. Yo, why cannot we convert light into matter? Well, I mean, in principle you can, but you need really, really high energy light. Not just high amplitude light, not just high intensity light, high energy light, like super X or super gamma rays. So let me hydrate a bit. All right. Do you think space-time topology can change dynamically, or is topology fixed forever in classical GR? I actually read a paper on this yesterday. They didn't really, the paper wasn't very convincing. They just kind of said, okay, well, here's a way that it could happen. I'm not convinced that that topology is fixed, but I think that we would need some good evidence to suggest that that's the case, or maybe some good theoretical virtues of the models that we produce that would imply that that's the case. Why do you think so many people believe the Earth is flat? Well, it kind of looks flat, and it seems really cool to be in an in club that knows the truth. If gravitational waves carry energy, how do you define that energy locally without breaking general covariance? You don't. You do break general covariance. You just do. I mean, you can do like boundary. You can do like boundary approximations. So you can have like a well-defined, what is it? A quasi-local energy that's defined in an asymptotically flat spacetime, but it's not clear if we're in an asymptotically flat spacetime. So yeah, I mean, we generally just assume that we're in an asymptotically flat spacetime, in which case you can just compute energy locally the way that you would like to. Craftinator says, I think you should hydrate again. Okay, look, if you're giving me money to hydrate, I will. If you sweep a powerful laser across the moon, the light spot can appear to move faster than light. That's true, but that doesn't mean that it's actually moving faster than light. Have you read the recent paper about baryon CP violation? If so, could you help explain it? I haven't seen it. Would you recommend pursuing a physics degree considering the future of AI? Look, if you're worried about AI taking your jobs, I think that it's probably going to take physics jobs. Like, as far as like intellectual jobs go, physics is probably not going to be the first that goes. So, how many donations does it take to give Blitz water poisoning? That's a good question. How much to take the hair down? 100K likes on TikTok, or several hundred likes on YouTube. Do you think quantum entanglement makes many worlds theory possible, or what are the holes in the theory? Quantum entanglement is compatible with many worlds. It's not exclusive to many worlds. Are the laws of physics emergent rather than fundamental? We don't know. That's a philosophy question. Please explain Nikola Tesla's 369 theory. It's nothing, and it is not worth spending time on because it's nothing. Can you discuss the hydrogen wall at the end of the solar system? Are you talking about the heliopause? So the heliopause, well, okay, let me just make sure. Let me Google hydrogen wall solar system, because if you're talking about the heliopause, I can talk about that. I haven't heard about this. Huh. Oh wait, no, this just seems like it's talking about the heliopause, which is the edge of the heliosphere. I think that's the appropriate name. So, oh no, this is a specific part of the edge of the heliosphere. Okay, that's interesting. I haven't heard about this, but maybe I'll make a video about it. I'll add it to my to-do list and see if I can learn something about it and then make a video. Hydrogen wall heliosphere. Okay, cool. Did you take a topology course? Hydrate. Okay, one sec. Hydrate, and then I'll answer. Funny story that. So when I was a second semester freshman year of undergrad, I did take a topology course. I enrolled in a point set topology course. The book was Munker's, as of course it is. And I was not ready for that class. So I was struggling to follow the lectures, you know, as 18-year-old me, struggling to do the homework. But I was like, you know, I was like hobbling along. And then came the first midterm and I bombed, so I withdrew from the course. So I never finished it. So I never ended up completing a topology class. When the further you look back in distance, you'll... Oh, I don't understand that question. That's not a complete question. Is space-time topology just the 3D mapping of space-time with all physics phenomena accounted for? Sort of. It's more like if you fix time-like slices, like what shape are those time-like slices? Think about like the way to think about this is imagine that you have like a donut that's like vertical. So you have like the donut like this and the donut hole here, and then you start slicing it this way. So initially your slices will just basically be like ovals, but then eventually it'll become two separate circles, and then it'll join back together to form ovals. So that's what we mean by like the topology of the space-like slices. It's just one dimension up. What's the slowest speed a thing can move at? Well, speed is always relative. So in principle, a thing can move at speed 0 relative to something else. What are your thoughts on purely particle-based physics models? So I actually saw a paper on that recently, but it was really, really boring, so I didn't end up reading it. I'm not convinced that they're the right thing to do, because particles are not like a conserved quantity. Depending on your reference frame, you might see a different number of particles, and that seems kind of confusing if particles are like the fundamental ontology. So yeah, I'm a little bit skeptical, but I could be wrong. Is there physics for phenomenal properties emerging from quantitative processes? Nope, that's probably not physics. That's probably neuroscience. Do sound waves, or philosophy if you like, do sound waves travel through darkness faster than light? Do sound waves interact with photons? Do sound waves travel through darkness faster than light? I suspect not, and almost certainly no, at least not directly. Sound waves are an emergent thing. Light waves are in some sense fundamental, or at least they're supposed to be. How would the universe be different if the weak nuclear force didn't exist? It wouldn't be that different, but there are some kinds of radioactive decay, well, some kinds of radioactive decay that just wouldn't happen. I guess also you'd have some problems because the electromagnetic force and the weak force are kind of two sides of the same coin. And so if the weak nuclear force didn't exist, I don't know how the electromagnetic force would behave. So there'd probably some weird stuff going on. What is matter-antimatter asymmetry? Yeah, so it's roughly this idea that, like, look, there's a lot of matter around. There's not a lot of antimatter around. Why is it mostly matter and not mostly antimatter? It's like most of the laws of physics are basically identical as far as matter and antimatter is concerned. So it seems very, very strange that we have more matter than antimatter. Assuming that you started at 0. 0 of both. Do you like cats? Yeah, I do like cats. Cats are great. Explain antimatter. Antimatter is just like regular matter, except all of the charges, like electrons have negative charge, all of the charges are flipped. They're flipped from negative to positive, or positive to negative. Everything else is basically the same. Everybody keeps bringing up the CP violation of baryon. I haven't seen this yet. But my guess is that it's on like some pop science website. Because there's a reason why everybody's probably talking about it. Was it like today? Oh, it was on Medium. Okay, well, I'll have to take a look at it later. What's your WPM? Fast. Do white holes actually exist? I suspect not. Does spacetime emerge from entanglement entropy? Maybe. That's one idea that comes from holography. We don't know if holography is like true, but it's at least an interesting mathematical idea. What's your view on string theory? I think that string theory is probably a correct theory of quantum gravity, just not for our universe. Like, it doesn't seem to apply to our universe, but it's correct in some alternate hypothetical universe. And so we can learn about how quantum gravity is supposed to behave qualitatively by thinking about string theory. Can you talk about the importance of the graviton? It's really not that important, but if we discovered it, we would just learn a lot about how gravity behaves on a quantum level. But like, it doesn't have to exist. Like, I think it probably does, but it's not like it wouldn't like complete everything. We would just be able to study it and learn a lot. Is gravity a consequence of momentum? Gravity is a consequence of energy, momentum, and stress and pressure. What's the great attractor most likely made out of? Just a bunch of galaxies. If you flew into a black hole faster than it could pull you in, would you still be ripped apart? Yeah. At a certain point, you would be ripped apart. It just might happen closer to the center than you would have otherwise experienced. What is the minimum math level you should master before going into physics? Well, at an undergraduate level, most of the math will just be kind of the stuff that, like the prerequisites. It'll be like the calculus courses, linear algebra, differential geometry, or not differential geometry, I'm sorry, linear algebra, differential equations. God, my nose is so itchy today. Must be, I don't know, something. C-Bar, thank you for the laughing disco. I appreciate that. Yeah, also probably dryness. What is the possibility of life forms based on silica? My understanding, and again, not a biologist, but my understanding is that it's not very likely because silicon doesn't like to form, the complex compounds that silicon forms are crystals. They're solids, and they don't dissolve easily while maintaining their structure. So you can't have like a soup of life where you have like a bunch of different solvents and chemicals reacting with each other, because these things are like rocks. So it'd be really hard to get life going that way. Is gravity an entropic force, or does quantum back reaction break that? So it's not clear if gravity is entropic. I've seen some papers that claim to demonstrate that gravity is not entropic. I've seen one paper that makes that claim, that like you can prove that this is not the case, that the idea fails. But I think it's still considered pretty fringe, but it's mainstream enough that people think about it. Is anyone doing experiments to detect gravitons? No, nobody has devices that are nearly sensitive enough to detect gravitons. Do you think we'll ever discover evidence of life on another planet in your lifetime? Well, we did discover evidence of life on Mars like a month ago. Now, it's not definitive proof, but it's definitely strong evidence. Blitz, are you 6'8"? No, I'm 7'11". Does many worlds have good evidence to support it? Many worlds is an interpretation, so all of the evidence for quantum mechanics is evidence for many worlds, but all of the evidence for quantum mechanics is also evidence for the Copenhagen interpretation. So what we don't have is distinguishing evidence, but as far as I can tell, no interpretation of quantum mechanics has any distinguishing evidence. Daniel Hart sends $2 to ask, what do you think about multiverse theory? Yeah, so there's a lot of different multiverses, a lot of different multiverse models, if you will. There's the quantum multiverse model, which is like, you know, it's many worlds, right? So each time a quantum process happens, the universe kind of splits, if you will. And so you get multiverses like that, but these are not like spatially separated. They're all kind of in the same place. Then you have kind of the cosmological multiverse idea, which is where the Big Bang was but one kind of pop in like a endless sea of expanding universes that each, you know, you'll have universes pop in randomly, basically, as a result of inflation. That's another idea. Those two ideas are both fairly reasonable to think about, but they're not really multiverses in like the Marvel sense. So, oh, by the way, I should mention a few things because we're, it is, well, I should shill for myself a little bit. So first of all, if you want your questions to be prioritized, because there are a lot of questions, there's probably, what are we talking, 600 people or so asking questions, I would estimate. So that's kind of a lot. So on the one hand, if you want to prioritize your question, the best way to get it prioritized is to send a super chat. Now, it's like $2. You don't have to, of course. I will answer other questions, but it's just the best way to get it prioritized. Second thing, if you want access to my debate notes, the debate notes, you can only get access through either the Patreon thing at like the lowest tier or whatever, or you can get access through being a member on either YouTube channel. It's like $4 or $5 a month. Again, not required, but if you want access, those are the ways to get it. You know, those kinds of things are things that help support this channel and help encourage me to do this more, and are the kinds of things that would encourage me to want to do this full time rather than taking a job at a university, for example. So, you know, supporting me, if you want more of this, that's a good thing to do. Anyway, let us keep answering questions. Is spaghettification real? Yeah, absolutely it is. If you were to fall into a black hole, you would absolutely have a really bad time. Ben sends $10, thank you, Ben, to ask, hey, I'm a physics student in high school, and I'm a bit confused on what the difference between energy and force is. Please explain it in simple terms. Also, what's a wavelength? I keep hearing you and Ian speaking about it. Yeah, so energy is a number that essentially tells you how much stuff is moving around or how much stuff has potential to move around. Force, on the other hand, is what causes motion itself. Now, it turns out, in order to apply forces, that will kind of cost energy, and that kind of makes sense. If you have a lot of potential energy, this is energy that can be spent to cause motion, then you have to use up that potential energy to apply a force because the force will cause the motion. So energy and force are very closely related, but they're not the same thing. A wavelength, on the other hand, is just the gap between two peaks of a wave. So imagine you have like a wave that's like this. The wavelength is just the distance between the two gaps, the two peaks, rather. Nectu, thank you for the power potion. I appreciate that. Germs sends $10. Thank you, Germs. To ask, I think I heard you mention you were trying to get a position at Baylor. I got one of my degrees there. If so, get in contact with Klaus Kirsten, math physics PhD, fascinating person. Yeah, I applied. Generally, these kinds of things you don't start hearing back until January anyway, so maybe we'll hear back in January or February. I've applied to like 50 places at this point, and I'll be applying for more in the near future. So we'll see. Flip asked, how's your postdoc search going? In my field, it really doesn't start till spring. Yeah, so in my field, the postdoc applications start going out in fall. And so I have now applied for, how many have I applied for? Let's look. Let's just pull up the numbers. I have applied for, okay, it looks like I've applied to like 35-ish places, and there's 75 on my list. The deadlines are, I'm basically caught up for all of the deadlines that are at the beginning. Actually, no, there's a lot more deadlines at the beginning of December that I have to catch up on. I'll probably work on this today or tomorrow. But there's like another 10 that are due at the beginning of December, then like another 10 that are due in the middle of December, and then a few that are due at the beginning of January. So, you know, we'll hear back. There was one position that I should hear back soon if I'm going to get it. It's a position at Case Western Reserve. I was interviewed. Who knows if I'll get that, if I'll be offered that position. Who knows if I'll take it if I am offered it, but we'll see. Jan Atu, thank you for the 25 Polish zloty. Hello, I always wondered about antimatter. How did it come to exist? Shouldn't there be the same amount of matter and antimatter in the universe? Yes, there should be. If you think that we started out at 0, then yeah, there absolutely should be at least approximately the same amount of matter and antimatter. So this is one of the biggest questions in physics right now. Why is there more matter than antimatter? Because there's just not a whole lot of antimatter in our universe. It's a really good question. Is there any physics breakthroughs that is very relevant right now? It depends on what you mean by very relevant. To me, sure. To you, maybe not. I wonder, as a physicist, are you a materialist when it comes to the question of consciousness, or do you believe in qualia? I mean, qualia like exist. The question is, what are they? I generally think that it's some sort of emergent thing. George sent £2 to say, can physics ground induction? No, of course not. That's a philosophical thing. Why is it not possible for any object with mass to reach light speed? Well, having mass means that you move on time-like curves. That's what it, in some sense, that's what it means to have mass. And if you move on time-like curves, then that means that your speed, by definition, is lower than the speed of light. But practically speaking, momentum doesn't scale linearly with velocity. And the amount of force you have to apply to increase your momentum, and in order to increase your momentum, you have to apply a force. So the more you want to increase your momentum, you have to apply more and more force. And so because the momentum asymptotes, or the momentum diverges as your velocity approaches infinity, as your velocity approaches the speed of light, you have to basically apply infinite force to get closer and closer to the speed of light. The force required diverges. Do you think physicists in 500 years will look back at now like you look back at Newton? You mean with awe and respect? I would hope so. Why energy is not conserved in Einstein equations? Please answer me. Yeah, so the Einstein equations has local energy conservation. Absolutely. And it's just trivially true. The stress energy tensor is divergence free, and that's local energy conservation, meaning that at a point, energy coming out is equal to energy, or energy going in is equal to energy coming out at a point. But globally, in order to have a global energy defined for the entire universe, you have to have what's called a time-like killing vector. And time-like killing vectors just don't exist in all spacetimes. What is Ohm's law? Ohm's law tells you that the relationship between the current in a resistor and the voltage in a resistor is related, or there's a proportionality there, and that proportionality is the resistance. Is the universe stuck in an infinite cycle of expansion and contraction? We don't know. It's like maybe that's the case. Reed Newton recognizing advances but laughing at some of his beliefs, almost certainly. Oh yeah, probably. Why does the Planck length exist? Why can't space be infinitely small? Well, space might be able to be infinitely small. The Planck length is not the smallest unit of space. It might be the smallest unit of measurable space, because just for instrumental reasons, measuring something smaller than that would produce black holes, which would mean that you couldn't measure smaller than that. But that doesn't mean that space itself can't be smaller. Is the holographic principle consistent with de Sitter space? That's not clear. That's an active area of investigation. Could there be a connection to the antimatter imbalance and the cyclical Big Bang crunch? Maybe not. Or, well, I mean, maybe, but something that is taken seriously, or that is at least, I don't want to say taken seriously because all of these ideas people read and write about, but there's this idea of the CPT symmetric antiverse, which sounds crazy. God, my nose is so itchy, it must be dry. It sounds crazy, but the idea is merely that the reason there's no antimatter in our universe is because it's in the other universe that's going in the other direction. So you have the Big Bang at the middle, then you have our universe going this way, and the antimatter universe going this way, and they're both running forward in their own time, but in some sense they both start at the middle, and then they both go in the other direction. Think of like that one, you know, that picture where you have like the Big Bang on the left and then you have Big Bang on the right, Big Bang on the left, and you have the big expansion going this way. Imagine just doubling that and putting it on the other side. The other side would be antimatter. That's an idea that people have thought about. God, my nose is so itchy. So annoying. If photons don't have mass, why black holes still attract them? Because gravity doesn't just act on mass. Gravity is a curvature of space-time, and photons travel through space-time. Was Newton a better physicist or a mathematician? He was a better physicist, I would say. He viewed mathematics as a tool rather than as like a means for its own end. Buy a humidifier? I have one. It's just not usually this issue. And in fact, like, it's been like pouring for the last few days, so like it shouldn't be dry. Phantom Menace sends £2 to ask, can info be sent faster than light? Quantum entanglement? No. So there's something called the no communication theorem, and I'll just pull it up. This is a theorem, not a theory. This is a theorem that's been mathematically proven. The no communication theorem. This is a statement. In physics, the no communication theorem is a no-go theorem in quantum information theory. It asserts that during the measurement of an entangled quantum state, it is impossible for one observer to transmit information to another observer regardless of their spatial separation. So you can't transmit information using entanglement. It's just not a thing that you can do. What are your thoughts on Eric Weinstein? I think he's a grifter. Maybe he's a nice grifter. I don't know. Like, I've never met him personally, but like I think he's a grifter. Clarify, does the electron have a radius or is it a point? Electrons, as far as we can tell, do not have a radius. They're not like it's not like a hard little ball in space. When you throw something up, when coming down, it reaches half height. Is it half of its speed? No, not necessarily. No, you could work that out. So in particular, so you can work that out just by looking at energy conservation. So the speed, so the energy that the ball gets from its speed goes as the square of the speed, whereas the energy that the ball gets from the height goes linearly with the height. So if you decrease the height by 2, then that means that wait a minute. So you're comparing when it's thrown up to when it's half of its height. Yeah, you could absolutely work that out. What you would find is that no, it shouldn't be half its speed. No. There's a square root 2 in there. If identity has symmetry, doesn't this theorem imply a law of conservation of cognitive energy? That's not how that works. No. Would the Higgs boson be discovered without the Large Hadron Collider? No. I mean, not unless we built another collider somewhere else. Nectu, thank you for the power potion, and Seabar, thank you for the laughing disco. Is the universe deterministic or fundamentally random? That is a good question. I think that it's probably deterministic in a quantum way. Is there anything which has the measure of the Planck length? Not as far as we can tell. We've never measured anything that small. Antimatter can't exist to be weighed. We've actually weighed antimatter. We can make antimatter, and we've weighed it, and it falls down. What is up with the second and third generation particles? They're just extra particles. They're a lot like the first generation particles, but they're heavier. I don't really have a good explanation for why they exist. They just do. Please explain to me the reflection of light through a glass slab and a glass prism. At what level? So anytime that you have a transition from one index of refraction to another index of refraction, you'll get some transmission and some reflection generally, as long as the transition isn't too severe and it's not going in the wrong direction. One way to think about this is, and this happens not just for light, this happens for literally anything. So if you take a string, like a thin string, and then you tie it to a thick string, and then you flick the thin string, you'll get like so that a wave travels down it, you'll get that some of the wave passes through to the thick string and it'll continue traveling through the thick string, but also some of it will reflect off the boundary. So any time that you have a change of speed, which is what the index of refraction does when it goes, which is what the change in index of refraction causes, you will have a reflection and transmission. Richard sends $5. Thank you so much, Richard. Quantum computing will have some uses where there is quantum advantage. Will there be tech advances you are excited about in other domains, e.g. comms? No, I'm not really interested in that kind of stuff. Yeah, quantum computing will absolutely have some advantages where we know that there are quantum advantage. Quantum computing will be used where there is quantum advantage, yes. It's just the places where there's quantum advantage are just, I don't know. I'm not so interested in computing to begin with, so like I don't really care either way. Per Landauer's principle, can we calculate the thermodynamic heat cost of changing light? Yes, you could, but that would just be a minimum, assuming that the bit flips are irreversible. Is time travel into the future possible with time dilation by going near a black hole? Absolutely, yeah. Have you always been an atheist, or did the knowledge in your field lead to that? Yeah, I've always been an atheist, at least as far as I can remember. What is antimatter and dark matter? So antimatter is just, you can see it, it's basically exactly like regular matter, except all of the charges are flipped. So instead of having negative charges for your electron, you have positive charges for your positrons. Instead of having positive charges for your protons, you have negative charges for your antiprotons. Otherwise, it's basically identical to regular matter. Dark matter, on the other hand, completely different. Has, as far as we can tell, has no charge at all. We can't see it. We have no idea what it is. All of that stuff completely in the dark about. See what I did there? Jam, thank you for the $2. I appreciate the thumbs up. Why can light go in light speed if it has mass? Light doesn't have mass. That's why. Does emergent gravity assume string theory is correct? It depends on which version of emergent gravity. Some do, yeah. Garain sends $5 to ask, what does it mean for a particle to be fundamental if it can decay? One of the heavy quarks, for example, that doesn't make sense to me. Yeah, so there's kind of two different notions here. So on the one hand, you have fundamental as in not composed of anything else. On the other hand, you have fundamental as in like it is the bedrock. And so actually, no, those are not two different things. So when we say fundamental, what we mean is that it's not composed of something smaller. Now, that doesn't mean that it can't decay. It's like a neutron, for example, can decay into a proton, an electron, and an electron antineutrino. But that doesn't mean that all of those particles are found in a neutron. A neutron is made of 3 quarks, right? It doesn't have a proton in it. It doesn't have an electron in it. So decay is just a process that can happen to a thing, even if it's not composed of anything smaller. And that's what we mean by it being fundamental. We mean that it's not composed of anything smaller. If they are flipped, doesn't that mean an anti-electron is just a proton and an antiproton is just an electron? No, because the masses stay the same. So an anti-electron has the mass of an electron, but the charge of a proton. And so like the masses aren't changed. Michael Padilla, thank you for the $20. That's huge. Let's get a W for Michael in the YouTube chat if we can. Is M-brane idea separate from a multiverse or a version of it? And is the idea that 2 flat membranes touch to cause inflation events and there's interactivity between stuff in those universes? Thanks, enjoying your work. So there's something called M-theory, which is like a souped up version of string theory. And there are multiverse ideas in string theory. It's called the string landscape. And this will appear in M-theory as well. The multiverse idea doesn't come from string theory, though. It doesn't come from M-theory. These are not like 2 sides of the same coin. Like there are theories of multiverses that don't involve string theory or M-theory at all. And Like, you don't have to have a multiverse in M theory. Now, the idea of two flat membranes touching causing inflation, that's a separate thing. Again, it comes from string theory and M theory. That's called the ekparodic universe. And it's just one particular hypothesis. It's not taken the most seriously these days. But it's something that people are, at least a few people are still working on. That's roughly the idea. Hopefully that answers the question. Oh, and Jan Atu with the 25 Polish zloty again. How do you think development of AGI or ASI, if possible, or AI in general, will affect mathematical and physics-related research? I think that there are parts of it that will absolutely be sped up. I currently have a subscription to ChatGPT. I actually use it quite frequently for finding literature and for finding background on stuff. So, for example, if I have a new research idea, which I had a new one yesterday, probably today or tomorrow, I'm going to be like, hey, I have this idea. Can you find me any references that people have worked on that is related to this idea? Just because it's a good way to make sure that somebody hasn't already written the paper. Because if somebody's already written the paper, I don't want to waste time writing a paper only to find out 2 months after I submit it to a journal that, hey, you didn't cite the people who originally did this. So I think that tools like ChatGPT will speed up a lot of these things and remove a lot or reduce a lot of wasted time. Now, do I think that it will actually help with the research? I don't know. I don't actually know how useful it will be for actually doing research. I think that it will be useful for finding references, for kind of finding the explicit things that you want to for a particular idea that you know exists or a particular idea that you want to work. That's my thinking. And Tim for Pele, thank you for the $5. Where do you land on the black hole firewall paradox? That firewalls exist, that we need a quantum gravity theory in order to resolve it, fuzzballs? I'm pretty agnostic about it, to be honest. I suspect that I don't think that firewalls exist, though. Like, if firewalls exist, that would be really weird, because GR should be totally well-behaved. GR should be totally well-behaved near the event horizon of a large black hole. There's like no extreme curvature there, so it'd be very, very weird if there was a firewall there for some reason. I wouldn't understand that at all. ChatGPT tends to hallucinate sources, which can be an issue for someone not used to citations. Yeah, so here's the thing. You can't rely on it. You have to actually go read the things that it sends you, but it can be very, very good at finding those things. You can treat it as like an advanced Google. Daniel, thank you for the superstar on TikTok. I appreciate that. All right, yeah, you have to look at the source, absolutely. How plausible is it for a fundamental law like the speed of light being the limit to be disproven? I think that there are some things that are probably not going to be disproven. The speed of light might not be one of them. The speed of light might be, like, we might see Lorentz invariance violations sometime in the near future. That's something that people are actively looking for. Does QFT and eternal inflation say that the universe is eternal? Some would say yes, some would say no. That's very, very contested. The superstar should make the host glow for a minute. Yeah, that'd be kind of neat. How could black holes exist? Well, when you have something very, very heavy in a small enough space, you get a black hole. What do you think of ETH Zurich in Switzerland? It has a very good reputation, or at least it used to. I don't know if it still has that good of a reputation. I mean, of course it doesn't have a bad reputation, but it used to be like one of the dominant schools in the world, right? You see the article where they prove the universe isn't a simulation? Yeah, that's bad science. They did a really bad job in that article, in my opinion. Sean, thank you for the $5. Sean asks, why is the speed of light the cosmic speed limit? It's unintuitive to me to have a literal speed limit. Well, look, so there's kind of like two ways. So the way that we describe the universe is geometrically. And there's kind of like two different ways that you could have had a universe that's described geometrically. One where you have a speed limit, and one where you don't have a speed limit. And it turns out we live in one where you have a speed limit. And maybe there are reasons for why that's the case. Maybe a universe without a speed limit just wouldn't work. I just had a really good idea. Hold on. I need to write down a project idea. Yeah, okay, sorry. Just had an idea based off the paper I just read. But anyway, so you could have had a universe where there is no speed limit, and you could have had a universe where there isn't a speed limit, or where you could have had a universe where there is, and you could have had a universe where there isn't. And it turns out that we're in a universe where there is, and that speed of light, that limit is just whatever, that limit is just however fast things can go that have no mass. And it's, you know, maybe there's a reason why you can't have life, or you can't have observers, or maybe like the physics just doesn't work in a universe with no speed of light limit. So in that case, then it makes sense that we find ourselves in a world where there's a speed of light limit. Nathan Irvine with the $5. Thank you. Is there an explanation for the double slit experiment? Yeah, it's something that we actually understand really well at this point. The double slit experiment is merely that. So the first thing to understand is particles are always waves. They're always waves. Sometimes they're particle-like waves, but they're always waves. So you send this wave through two slits, and if you're not doing anything to them, those waves kind of preserve themselves, and they pass through the two slits and they interfere with each other because they're the same kind of wave. They can interact. However, once you get information about which slit it can pass through, that information is encoded in a quantum entanglement between the wave and the thing that did the measurement. And so now you have two different waves passing through the slits. You have one wave that is entangled in one way with something, and another wave that's entangled with something else in another way. Or, sorry, you have one wave that's entangled in one way with something, and the other wave that's entangled in the other way with that same thing. And so now those two waves aren't the same, so they can't interfere. So you just get two big lumps. This just has to do with how measuring which slit the particle goes through affects the wave function of the particle, and it causes entanglement. That's what makes it happen. Ben Piz with the $10. What is accurate and what is fictional about Interstellar's portrayal of Kip Thorne's model of a planet orbiting near the event horizon of a nearly maximally spinning supermassive black hole? Basically, all of it was accurate. Basically, all of it. I mean, I'm skeptical that you could even have a planet there. I'm skeptical that such a thing could form and that it would be warm enough to have water. But like, given all of that, like maybe there's some special conditions that make that the case. Totally accurate. So every particle entangled is connected by a small wormhole. Not necessarily, no. What are the most promising experimental approaches being used to search for Lorentz invariance violation? I haven't looked at the experimental literature on this, so it's just not something I've been looking into. I imagine that that if it happens, I will hear about it and then I'll look into it. How do we calculate the speed of light? This was first done by, I want to say, by Hippolyte Fizeau. Yeah, he was the first guy to measure it like kind of on Earth, just by measuring the speed of something. And so basically what you can do is you can take a really fine-toothed gear, you can shine a light through one tooth, have it reflect off of a faraway mirror, and then come back to the next tooth. So basically you just time the rate at which the gear is spinning at. And once you get it so that it perfectly comes back through the next tooth, you can use the speed at which the gear is turning and the reflection distance to figure out the speed of light. It's a really cool experiment, and I think I even made a video about it a while ago. Is dark energy a constant force? Apparently not. There's data coming out over the last few years that suggests no. We thought it was for a long time, though. Or at least I thought it was. Many people thought it was. How is E equals mc squared? Like, how does the speed of light alone have anything to do with the energy and mass? So you have to look at where this equation first came from. This equation came from an examination of the amount of inertial mass that an object will have if it has an electric field. So if you take two charged particles, say 2 electrons, and you put them in a box and you hold them still, then you could ask, how much more does the box weigh by having those 2 electrons in your box? Now, you might say, if energy doesn't contribute at all to the mass of the thing, then it's just however much mass the electrons have, that's how much more the box would weigh. That's how much, and when I say weigh, what I mean is how much harder it is to push the box to get the box to start moving. However, what Einstein did is he was just very, very careful. And he basically showed that putting 2 electrons next to each other means that there's energy, the energy stored in the electric field that's produced between the 2 of them causes the box to be even harder to push. And so that energy corresponds to additional inertial mass of the box. And of course the speed of light is going to appear there because the speed of light is involved in all things electromagnetic. And then we found out that the speed of light is actually fundamental. It's a fundamental constant. It's not just a feature of electromagnetic stuff. Phantom Menace sends £2 British to ask, light can't escape black hole. would make it faster. I don't understand what that question means. Is the universe expanding faster and faster, or is it slowing down? Recent data, a very, very new analysis suggests that it's slowing down, but this is still very tentative. What do physicists mean by color in subatomic particles? Yeah, that's a good question. So we talk about the quantum color force, or the quantum color charge. This is used as a metaphor. And so typically we think of electrons having positive charge and negative charge, but there's another kind of force, which is quantum chromodynamics. This is the strong nuclear force that has 3 different kinds of charges. And each of those kinds of charges has its own anti-charge. So it's not just like positive and negative. There's like positive 1 and negative 1, positive 2 and negative 2, and positive 3 and negative 3. And then it also turns out if you combine positive 1, positive 2, and positive 3, then you get 0 again. So there's some metaphor that you can make to, like, say, color neutral. And so if you take like red, green, and blue, like in like the theory of light, if you take red, green, and blue and you combine them, you get white, right? You get like a neutral color, if you will. You get white light, which kind of doesn't have any color preference, and so you could say that that's neutral. So it's a useful metaphor that you have red charges, blue charges, and green charges, and you have anti-red, anti-blue, and anti-green. So you can form neutral by either red plus anti-red or by red plus green plus blue. Jay, thank you for the $2. I appreciate that. I think it means that the energy from the black hole absorbing light would increase its mass in a way that would seem like it's sucking. I don't understand that still. The Higgs potential seems to be metastable. Do you think it's just nature, or do we miss something? It might just be its nature, yeah. How do you feel about the new evidence supporting the Big Crunch? I think it's really cool, but we should be very conservative here. We should not form beliefs more than the evidence suggests we should. I know that there's a phrase for it, but I can't think about what that phrase is. There's like a really famous, philosophically sounding phrase, but I don't remember what it is. So just, be skeptical. How many years did it take to accumulate such a high level of knowledge? Well, I went to school for a long time. I did 4 years of undergrad, then I did 7 years of grad school for a master's and a PhD. Proportion our belief to the evidence. There you go. That's the right phrase. Thank you, Ryan. If you were immune to any detrimental effect, what would you want to witness in the universe? Well, if I could leave, I would want to join a black hole. That'd be pretty, or enter a black hole. That'd be pretty neat. How to determine if a source is credible when doing research? I do a lot of online research, but I like to make sure my sources are credible. I guess it depends on what kind of research you're doing. If you can find it in an academic source, like a published journal, and if that journal is a legitimate journal, and you can check this by looking up its impact factor and then comparing it to the impact factor of like the big journals in the field. You can just Google, is this journal legitimate? Is it pay to play? Is it predatory? Blah, 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 blah. If you have an academic source, like a published article in a academic journal, then it's almost certainly credible. Beyond that, though, it takes a little bit more, I guess, experience in doing this, right? Like, you have to go find places that cite their sources if you want to use them as references. Or if it's on a .edu website, even then it can be a little bit iffy. So yeah, I mean, it's a tricky thing. It's a tricky process. I eat Physicist for breakfast. That's a weird claim. Just ask ChatGPT instead of paying this guy. Well, look, ChatGPT gets some things wrong, but absolutely, you could ask ChatGPT a lot of these questions. If you don't want to watch here, you can just go ask ChatGPT. Do you believe in Planet 9 theory by Konstantin Batygin? No, I don't. He said he's not a trained physicist. I don't understand what he's yapping out. Wait a minute. Who said that I'm not a trained physicist? I have a PhD in physics. What? I'm absolutely a trained physicist. That's like what I am. That's like my whole bit. That's like the whole thing. Right? As long as it is from the elitist club called academia. Well, academia is really not that elitist. What it is it's exclusive because it excludes bad ideas. Shaideshe with the 15 shekels. Can you explain how Hawking used imaginary time / Wick rotation, not just what it is for deriving Hawking radiation? No, because I haven't read the paper in a long time, and I definitely didn't internalize the derivation he did, because the derivation he did I thought was kind of messy. But I did a video on this a while ago where I referenced another paper that derives Hawking radiation using quantum tunneling, which I think is a lot more intuitive. But no, unfortunately, I can't. I just don't remember the method that Hawking used to derive Hawking radiation in his original paper. I have to go look at those. Sorry about that. Do boundaries or horizons change the rules of physics? It depends on what kind of boundaries and horizons you mean. I mean, like black hole event horizons, not really. Cosmological event horizons, not really. If the universe had like a physical spatial boundary, that'd be kind of weird, yeah. In an attempt to find a theory of everything, why is the tendency to quantize gravity, i.e. have a graviton instead of gravitizing QFT, especially when this approach hasn't worked for 100 years? So people aren't really trying to quantize gravity in like the QFT way anymore. I mean, some people still are, like that's what loop quantum gravity is, but it's kind of like fallen off. People are trying to be a little bit more creative. And the reason is because we know that quantum mechanics is correct, and now QFT might not be like the correct paradigm for it. There's maybe some other quantum paradigm that we need to invoke, but like somehow we need to make gravity, we need to figure out a way to include gravity into whatever quantum paradigm we're talking about. And like we can already do QFT in a curved spacetime. The question is I don't even know what it would mean to gravitize QFT. QFT is the description of certain symmetries. And, you know, the associated fields and so on. I just don't like. Like you could try to incorporate gravity into QFT, if that's what you're asking, and that's what people have failed to do. Does E really equal MC squared, or was Einstein just a narcissist who left his family? Well, he may have been a narcissist. I don't actually know if that's a correct description of his personality, but yes, E really does equal MC squared, at least for an object that's not in motion. Oops, did not mean to do that. I only have an education in the history of the philosophy of science. I often wish science track degree programs would make their overblown technicians learn the history and philosophy before doc. Okay. I don't know if that was a question. Is it outside the realm of you ever doing a day in the life of Dr. Blitz on YouTube or stream? I mean, maybe. It's like, my days are very disjointed. Days are very rarely like other days. Well, okay, that's not true. They're often like other days, but they can be very disjointed, and it would just be very boring to have a live stream of me all day, just kind of like reading or running a calculation or something, right? Is simulation theory possible if an external source dictates each scenario? I mean, like, I don't think it's likely, and I don't think that we have any reason to think that it's true, but like, is it metaphysically or logically possible? I guess. If it isn't in motion relative to what frame is in everything in motion? Yeah, so the energy of a system depends on what reference frame you're measuring it from. So with respect to a reference frame where the object is not moving, then the energy of that object is just MC squared. With respect to a reference frame where the object is moving, then that energy is not just MC squared, it is the square root of MC squared plus the momentum times the speed of light squared. Aaron Bailey with the $5. Thank you, Aaron. I'm a nuclear med technologist. How are photons particles? That would consider them matter, which contains mass, but they're massless. So being particles doesn't mean that they're matter. Matter doesn't necessarily have mass. So there's just like a disconnect here. Like you can have massless particles. You can have massless matter. Now, it turns out that all of the matter that we know exists doesn't have mass because of the Higgs mechanism, and recently we discovered that neutrinos also have mass. But neutrinos didn't have to have mass. Like, it could have been, like, there's a possible way that you could have had laws of physics where neutrinos, which are a type of matter, a type of particle, that don't have mass. Similarly, you have types of particles, W and Z bosons, gluon, or W and Z bosons, and yeah, I guess those, and the Higgs boson. These are not matter, arguably, because they're not fermions, but they have mass and they are particles. So it's just like the link between matter and particle and mass. These are not surefire links. Shadeshi says I missed the super chat. I absolutely did not. I read it. It was this one. It was the one about Hawking. Why is it light squared? That's what the physics says. It has to be. Can you potentially view antimatter? Yeah, antimatter would look like normal matter. It would just be exploding all over the place when it ran into regular matter. How do you square light? You don't square light. The speed of light is a number, and you can square that number. Did I miss his explanation of gravitational lensing and how it's possible to see a star 28 billion light years away? No, I haven't answered that question yet, but I didn't even see that question originally. So the furthest things that we can see are like 30, 35, 36 billion light years away. And that's just because that's where they are now. That's not how far away they were when they emitted their light. When they emitted their light, they were like, you know, maybe 3 or 4 billion light years away or something like this. Now, usually we can only see galaxies, but if you have a really, really bright star that's like super, super bright, especially in the early universe, these stars were very, very bright, then it's possible through gravitational lensing, which is just basically puts another huge lens in front of your telescope, you could potentially see something that's see an individual star from that far away, which would be really cool. Do you think there might be another side to a black hole? I suspect not. Is the speed of dark matter measurable? Kind of. We can. So the data that we have is consistent with the dark matter moving slowly. Do you like the movie Back to the Future? Yeah, I think it's a good movie. Are tachyons still being researched as potentially being faster than light? Not really, no. Didn't Lorentz do all the calculations for Einstein's theory? No, Lorentz did some of them, but he didn't have the physics stuff to actually come to the conclusions that Einstein did. How could you hypothetically manipulate gravity? There's nothing hypothetical about it. You just have to move things around. I'm creating gravitational waves. I'm creating gravitational waves. It's manipulating gravity. It's just the manipulations are small because gravity is really weak. Where is the antimatter? Isn't there supposed to be a lot of it, or is that dark matter? What's the difference? So there's lots of dark matter. There seems to be no antimatter around, or very, very little antimatter. We don't know where the antimatter is. It's called the baryon asymmetry problem. There should be a lot. You're right. I don't know why. I don't know why they're not there. Nobody does. Shidesh sends 30 shekels. Thank you, Shidesh. I wondered if you heard about the connections between ADS-CFT and computational complexity, e.g. toy models for holography, and what do you think about them? I'm a PhD in quantum cryptography. So I've heard some stuff. I know that Lenny Susskind had some, had like a conjecture about using ADS-CFT, that like the volume, like space-time volume, is proportional to complexity. In fact, that was actually like, you know, a good 10 minutes in my qualifying exam when I was giving my qualifying exam for my PhD. I'm not so convinced that this is like a useful way, like a useful direction to go. I think that there's a lot of people who are trying to connect quantum gravity and like information stuff, and I'm just, and maybe this is just bias on my end, I'm just not convinced that that's like the right path. I'm not sure if like information is the right way to go. Have I met Susskind? I haven't met him personally, but I actually knew his grandson. I went to high school with his grandson. Karen Jervis sends 2 British pounds. Can you discuss how Planck temp links to gravity? So the Planck temperature, let's just look at what the constants are. The Planck temperature it's just a temperature. It's some number of Kelvin, and it's just going to involve these fundamental constants like the speed of light, the gravitational force, Boltzmann's constant, the Planck's constant, and so on. And so the Planck temperature in particular is, sorry, I just want to find the derived one. Yeah, so this is the square root of Planck's reduced constant times the speed of light to the 5th power divided by the gravitational constant divided by the Boltzmann's constant squared. And like, it's not necessarily a thing that's meaningful. It's just a natural way of describing a temperature, like a unit of temperature in terms of fundamental constants. And I guess if you have an object that is at that temperature, it would emit light with the Planck length wavelength. So that's like a useful thing, I guess. And so I guess quantum gravity would show up there, because photons with that much energy would probably create black holes. Is it possible to build a communication device with entangled matter to communicate over long distance? No. Not with solely entangled matter. You could use entanglement to kind of encrypt your data, but you can't use it for the communication part. Do you believe dark matter is actually matter, or do you think general relativity is incomplete? I think it's actually matter. How do you explain how the highest IQ man in the world believes in God? Well, I don't know if that's true. If you're talking about the Korean fellow, I don't think he has the highest IQ in the world. I think that he kind of made it up. The exam that he took was an exam that was hosted by an organization that he owns, I think. So like, it's definitely not unbiased. Are misconceptions within subsequent understanding of physics common, such as Hooke's law being true? I don't know what you mean within subsequent understanding. Don't black holes get created at much lower temperatures than Planck temperature? The Planck temperature is very, very high. It's not very, very low. It's very, very high. But yeah, the idea is that if you had something that was hot enough to be at the Planck temperature, then it would be emitting light that has energy. It would be emitting light that has wavelengths smaller than the Planck length, and so those photons would collapse to black holes, or at least in principle they kind of should, or at least a pair of them would collapse into a black hole. Why doesn't the Higgs boson add mass to a photon? Well, if it did, then it wouldn't be the photon. The Higgs boson gives mass to 3 of the 4 particles in the electroweak force, and the one that it doesn't give mass to is defined to be the photon. So, because it can only give mass to 3 of the 4 particles for kind of complicated reasons. What do you think causes gravity between everything? I think that it's the curvature of space-time. That's the best model we have. How do you determine the contour for integration with the residue theorem? Well, that's up to your personal creativity to figure out the right contour that will let you use the residue theorem to compute some integral. That's like where the practice comes in. Oh. But it's actually, okay, that's not a question. Kerblin sends $5. Thank you, Kerblin. What would be your plan B if you didn't want to pursue physics? Well, mathematics. It's just an easy answer, unfortunately. If you mean not math or physics, I don't know. I didn't really have a plan B. Views on Donald Hoffman's idea that space-time is doomed and is not fundamental. That's not Donald Hoffman's idea. That is not Donald Hoffman's original idea. Donald Hoffman has not contributed to physics at all. Do you think space is quantized, and if so, would that mean that time is quantized? If space is quantized, then time should be quantized too. Yeah, that seems right. What do you think about it? What do you think it is about an object's amount of mass that bends space-time? It might just be look, so a lot of physics, it's not clear that there are answers to why for a lot of these things. Like it's just not clear that that's the case. Do you believe the simulation theory of the universe has a possibility of being true? It's like logically possible, but I don't think it's actually true. Are you currently working in the field? Absolutely. Yeah, I published like 3 or 4 papers this year. Actually, let's go look. Let's go look how many, I say published. I've submitted for peer review 3 or 4 papers. Peer review takes a long time. So the papers that I have submitted for peer review in this past year, yeah, I've submitted 4 papers in the past year, and then I submitted, geez, that's a lot in 2024. Okay, well, 2 of these are kind of a copy of each other. So I did 1, 2, 3, 4, 5, 6 papers in 2024. So yeah, I'm active. Can virtual particles be linked to dark energy? Probably not. 69 Kamsi sends £2 Does physics confirm or disprove free will? Physics kind of assumes that free will isn't real, insofar as, like, if the laws of physics are true, then what that means is that they're true everywhere, which means that the laws of physics are fundamentally what determines what happens in your brain, which determines your actions. Where can you find my papers? You can't, because I don't make them, I try to keep them not connected to my public-facing persona, because I already have one stalker. I'd like to not have more. Cognitive Dissonance sends $5 to ask, Dr. Blitz, why do you think BHC is a likely explanation for the creation of the universe? What's the most compelling evidence or data against it? BHC? I don't know what BHC is. Oh, black hole cosmology. Okay. I don't think that we're in a black hole. I don't think that there's any evidence that supports that we're in a black hole. Like the whole stuff that, like, oh, the universe is roughly the size of the like Schwarzschild radius, like, those two things are unrelated. In order for a black hole to form, you have to have stuff outside the black hole, or you have to have nothing outside the black hole. But we have no reason to think that there's nothing outside of the observable universe. There's just no evidence to support it. It's like and we don't have any way to, we don't have any, like, proposed mechanism by which you can have a universe that forms inside a black hole. Like, this is not, okay, well, I mean, there are some proposed mechanisms, but these are not, like, well-founded. What are your thoughts on Norton's dome? I think it's interesting. I think that this is an example of the failure of mathematics to describe something physical, which happens sometimes. Just doesn't happen often. How the cosmological constant works. It might not. In fact, I actually don't think that there is a cosmological constant. And I wrote a paper last year, was it? When did I write this? Yeah, this was in 2024, the middle of 2024. I wrote a paper in 2024 that kind of provides at least a baby toy example that shows that, you know, there shouldn't be a cosmological constant. If you spam your question, I'm not going to answer your question, and you might even get muted. Oh, shoot. I actually have to end the live soon anyway. I'll probably end it now because I have to get ready to go because there's an event happening today. I can't tell you about it because it's not my place to tell, but there is something happening today that I'm excited about, so I got to go get ready for that. So everybody, thank you so much for being here. Thank you so much for watching. Remember, if you want to ask me questions, if you want to get announcements, join the Discord. There is, if you're 18 plus, there's a link to the Discord server in the descriptions on YouTube, in the link tree in my bio on TikTok. Join the Discord. Second thing, if you want access to my debate notes, consider becoming a member of either YouTube channel. It's like $4 or $5 a month, or becoming a member or a patron on Patreon, like $5 a month. You can get access to the debate notes. Oh, and then also make sure to go subscribe to the second YouTube channel at Dr. Blitz Debunks. I'll see you guys tomorrow for some more debates.